Okay. Getting locked. Maybe keep it open. So now we can start now. The recording is also going on.
Okay, great. Welcome to this month's edition of Big Data Bellevue. My name is Siddharth Agrawal. I'm the organizer. My co-organizer is Chaitanya, who's also at the meetup. We've been running this meetup for about a decade, keeping track of big data development. We started in Hadoop days and then moved into Spark. And as you can see, Spark is still around very much and very popular. So a lot of big data has to do with processing and handling large data workloads, especially for analytics purposes, which means you got to run a lot of queries against the data. And if you can, one of the challenges always is, how to accelerate those queries. And as an analogy, if you think of the way a virtual machine works, it switches contexts between different, instances of the user context, but within each one, it executes them locally on the CPU, and therefore it gets good performance. So similarly, today's discussion is about an Apache project, Apache Gluten, which enables a SparkSQL engine to interface in a generic way with highly optimized libraries that run on the local platform. This is like a very high level view of this topic. One thing I can say is that this technology is in use today. For instance, Google Cloud is using it to accelerate its Spark SQL workloads. And so I am certainly interested in learning more about, what is happening under the hood. So with that, I would like to introduce this month's speaker, Binwei, who is the founder also of Apache Gluten.
So Binwei,
go ahead, Binwei.
Okay, thank you, Siddharth. Thank you. So good evening, everyone, and welcome to join the meetup today. And it's my honor to have a talk today here. And if you have any questions, so you can interrupt me and write your questions. I can answer you. So we needn't to wait until the end of the slides. Okay, today I will introduce the Gluten project. It's Apache Gluten. It's still in incubator. It's not graduated yet, and it's a middle layer to offload the SparkSQL using SparkSQL engine to the native libraries. And below are the GitHub link and the LinkedIn page. Okay, so my name is Binwei Yang, and I'm currently a newer IBMer, and I'm ex Intel. So I just left Intel in December and joined IBM on December 9th. So it's the first month, second month actually in IBM. And I'm the initiator of Gazelle and the Gluten project. So I will introduce what's Gazelle and Gluten later. And I lead the Gluten team in Intel previously, and currently I'm still working on the Gluten project in IBM, and I still lead the team in IBM now. And here is my GitHub profile chart. So if you find the three houses there, so it's me everywhere. It's a GitHub or Slack, so you can find me there. And also I want to highlight that so many guys asked that how large a Gluten team is in Intel. You did so amazing project. Actually, we have nine people there, including me, and they are Yuan, Rui, Hongzhe, Rong, Chengcheng, Ke, Feilong, and Wei Ting. So it's a really amazing team. And in early days, we contributed all the PRs, and currently we still contribute about 1/3 of the PI in the Gluten project. So they are still in Intel today. Okay, today we will have 20 slides and we will cover several topics. Firstly, it's the introduction, of course, and then the current status and the functionality, community, and the customer adoption stories. I can share more, and then it's the performance and the plan. Eventually, and last, I will have a QA. Yeah, hopefully we can finish earlier, and so we can give back several minutes for you guys. So what a gluten is? So it's the first question. What a gluten is? Actually, the short answer is that gluten is the open source version of Databricks Gluten. So what Databricks Gluten did is what we are doing in gluten now. So firstly, it's transparent to the SparkSQL. It's transparent to the end user of the SparkSQL. You needn't to modify any SparkSQL statement. You can use the same. So it's transparent to the business group actually. So only the Spark maintenance team needed it. And then what we did is that we insert the SparkSQL require plan, get the physical plan, and convert it into the substrate plan, and send the substrate plan to the native libraries, different native libraries. And the gluten itself, it's a plugin, it's a Spark plugin. So thanks to the Spark design currently, we can easily add the plugin into the Spark framework. And then inside of the gluten, there are several big components. One is the plan conversion, obviously. So we need to convert the Spark plan, physical plan to the substrate plan. And secondly, it's the memory management. We need to reuse, everyone knows that the Spark memory management, unified memory management is very important in Spark. So we need to reuse and the native support of the memory management manager. And then it's the SAFO. You know, the SAFO is I think it's the most important part in Spark. So we have a columnar SAFO support in gluten. And the similar is used to support different Spark versions. So we need, because the customer use various Spark versions from 3.2 to 3.5 today. So we need, because different Spark versions have different APIs, we need to support all of them. So we under a similar there to support. And another important is the fallback. So it's one big advantage when we designed the gluten project. We didn't implement all the features of Spark. We use GenAI, and we can easily fall back to vanilla Spark once we don't support or we have worse performance. And then it's the metrics. So what you see from Spark UI. So we got the metrics from Velox or from ClearHouse and show in Spark UI. So those metrics are essential to analyze the performance, find the bottleneck, or tune the performance. It's a very important part. And currently on the native libraries, we currently already support the Velox. So the Velox is what we worked with Pedro in Meta very closely on this. And also when we started the gluten project, another initiator is called Chen Chang. His company, he's from Cleveland. So his company wanted to use the ClearHouse because their product use ClearHouse more, and they are more familiar with ClearHouse. They think the ClearHouse have better performance. So I spent one afternoon worked with him and convinced him that we should work on this together instead of create two different projects and compete each other. So that's why we can reuse most part of the plugin here, and but we can offload to different native libraries. And then with the Apache Arrow, obviously we can use the Apache Arrow computer, but currently we only use the CSV partial in Apache Arrow project. And eventually we worked with several other companies on the FPGA, GPU, and ASIC accelerators. So they wanted to use under accelerator support, and also we want to do that. Yeah, so this is the simple introduction overview of the gluten project. Yeah.
Can we ask you questions as you go, or are you?
Yeah.
As you go.
Yeah.
Maybe a quick question on the fallback piece that you mentioned there, because are you talking about there's maybe certain types of aggregations or operations that are not able to be passed to native execution, that fallback goes back to the Spark? Is that what you're talking about?
Yes.
What are some examples of where you see patterns or operation types that always need a fallback, or that Gluten hasn't been able to cover yet?
Yeah, so the Spark functions, if a Spark function is not implemented or the customer UDI is not covered by the native library, we need to fall back to it.
So if it's not in one of these like libraries, or is it more common? I was wondering if there's like certain like aggregation types or it's more tied to library specifics. Is that?
Yeah, so currently we have covered most of the data types and most of the functions that will cover, so the details to the table. Yeah. Okay, so this is how the gluten works. So what we want to do is that we reuse the Spark scale out framework as a control flow and optimize and offload the performance critical part to the native libraries. So everything, the stuff, how the data is suffered, or how the control plan, how the physical plan is created, what's the physical plan, the counter list, everything, it's still use the vanilla Spark. So only when we execute these operators, then we send it to the native library. And here is how it works. So we have a driver mode, we have a worker node, and in each worker node, we have several executors, and then in each executor, we have several task threads. And inside of the task thread, we check that if the operator is supported in the native library supported this operator or this functions, it's all this query plan, the whole query plan. If it supports, then we use a GNI to call the native library, send the plan as the substrate format to the native library, and then get the data bank. And actually, it's a pointer of the data. It's not the real data, so it's still in the Velox format or the ClearHouse format, and then for bank to, and then transfer to bank to vanilla Spark or to different libraries. And when the vanilla Spark need to access the data, then we add a column to row support and then convert the data from a Velox format to the Spark format, and then the Spark row format, and then use the Spark SQL engine there, the GBM-based SQL engine. And if the GBM SQL engine finishes its work, then we can add a row column and then convert it to the Velox format, and then use the GNI call to the native library again. So in each stage, you can easily for bank one operator to native library, or sorry, offload one operator to native library, and for bank the others, you can go back and forth several times if you don't care about performance, because each column to row and the root column is expensive today. So, but in theory, it can support, you can easily fall back that. So this is how it works. So it only works inside of the task thread.
Maybe another small question if I could. This makes a lot of sense here too. So you have to deploy and manage a separate compute or that you're going to be running with ClickHouse, Velox, or third-party engines, right?
Yes.
For this to go. Have you observed from the community engagement of one of these engines being more often used with Gluten than others?
Currently, it's an interesting question. Yeah, it's a good question. So when we work with clients, we make a deal that we don't compete each other. So we don't measure performance each other. Internally, we did measure, but we agreed and never see the data. Yeah, it's customers. Yeah, customer can measure that. Actually, those ClickHouse and the Velox, we can very easily run the TPC's workload on both. Yeah, and yeah, the customer. So what I can say is that until today, most of our company, most of our customers use the Velox backend and yeah, compared to ClickHouse.
Sorry.
Yeah.
I'm kind of curious. So like, can we dynamically select which the engine?
Oh yeah, it's another good question. So currently the Velox and ClickHouse we cannot, but we under Velox and Arrow support, so we can dynamically switch from Velox to Arrow and to Velox. But Arrow, the Arrow library, its performance is very bad. We only use the CSV today. Yeah, I have an example there later. And this is the Gluten journal. So actually, here is the data breach Fulton released in October of 2021. And before, long time before that project, actually we started the Glue project in Intel, and it's in May of 2019. So it's 5 years ago. Oh yeah, it's 6 years ago almost. Yeah. So the Glue, what the Glue does is that when I joined Intel, the big data team, yeah, when I joined the big data team, my task is that I need to offload the SQL engine to a native library, to a native accelerator. And when we did the FPGA in Intel, we did the FPGA also offload many times and many for different versions or different framework, different cases. But what we noted is that For the FPGA, we can easily get a performance boost for a single operator. For example, the compress or the hash join, we can get the performance easily by a macro. But when we integrate into the Spark, performance is bad. So the performance boost is little or none. And when we offload a new accelerator in Intel, I told my manager that no, it's not the correct way. So we should offload everything to the native library, and from native library to the accelerators. And then at that time, we don't know about the Velox project. So we wanted to use Apache Apache's computer engine there. We did write lots of operators. So we implemented the operator in Apache Arrow and offload it from Glue to the native operation, the Apache Arrow's computer engine. And at the same time, I made the main designer of the Rapid plugin, and in NVIDIA, actually, we started the project almost at the same time. So we know each other there. And what Glue does is it's different from Gluten. So what Glue does is that it offloads every operator to the native library to Apache Arrow, and then get the data bank. The control is still in Java. The control is not in the native. And later, we noted that the Glue project is we did have a performance boost, but it's very hard to get the customer because the computer engine is too complex. We only at that time we only have 2 people working on that, and we cannot implement the whole SQL engine. And then we, Dave Cohen introduced me to the Databricks, to the Meta, the Pedro and the Velox project. And I noted, oh, this is the right project. So we wanted to offload the Velox. And then we found that during the Glue design, we noted that so you offload one operator to native, then go back, it doesn't make sense. We should offload the whole states of the current plan to the native, and let the native engine to pass the line, start the pipeline, and the end of the pipeline, it will return back to Spark. So, and fortunately, at the same time, the substrate project is created. So I talked with Jack and many times at that time. And we worked with him very closely and contributed a lot to the substrate project. And we converted the whole plan to substrate and offloaded to the native. So it's a history. And then we started working on the Velox backends. And here is a great, it's end of 2021, we started the Gluten repo. And then in 2022, we want to pass the TPC-8, TPC-DS, and then get a performance boost number. And in 2023, we still improve the performance number there. You can see, and we add more Spark support, Spark version support. And at the same time, we started to get the customers, so get more and more customers in 2023. And then something I wanted to highlight is that in 23 in July, we started with PKG there, and I will cover more here. So then we spent in October. One big thing is that we switched to the upstream Velox. So initially we worked on our internal Velox because the Velox community we need to implement the feature very quickly, but the Velox community review is slower. So we just implemented natively internally, and later we found that it's not maintainable. It's not it doesn't work anymore. So we switched to upstream Velox, contribute most of our PRs to the upstream Velox. So today we still use our OP Velox today, and we only have 10 more commits not merged into upstream. So we still there. And then we under data lake support, we under view support under UDF's framework, so customer can implement their own UDF. And in last year, we contributed to Apache. So why we contribute to Apache, it's actually one requirement from Microsoft and when we worked with them. So they want the Velox governance is not good, we know, and they wanted the Gluten to be good. So we contributed to Apache. And then we continue improve the performance number. And in August, we have the first Apache release there, and we implement salt-based shuffle. So initially, we only have the hash-based shuffle and under server test. And so it's most recently, we under SMG support, we under PerfScript, the partial project. I can cover more under Rust cost model. So this is a gluten journal in simple.
Do you support Spark, are you on Spark 3.5 yet, or is that?
It already supported.
It's already.
Yeah, Spark 4, not yet here.
Oh.
So yeah, this is a coverage. This is a coverage. So currently Spark have.
One more
Yeah,
question.
yeah.
So, is the IO still handled by the Java JVM, and then after the IO it's passed on to the operators, or is IO itself is done by Gluten?
And you mean the IO?
Like reading from
Oh.
S3.
Oh, yeah, everything is offloaded to the Velox and the ClearHouse. It's a native.
I see. Velox actually reads from S3.
Yes,
by
read
itself.
from S3, yes. But the Spark still need to access the S3 for the metadata. So, yeah, but all the real read work is offloaded to native.
And in the previous slide, you also covered about data lake support.
Yes.
How much of that extends to Velox? How much of data lake stuff does Velox need to understand?
Yeah, so all of this data lake support needed to be known by Velox. The Velox needed to under support there. Yeah. Yeah, so this is the coverage, the functions, operators, the most commonly used and the customer required. So you can see that most of operators is not frequently used by customers. So this is what we collected from our customer there in Intel, still Intel. And the functions is the same. So we implement Spark implemented lots of functions, but commonly used is the number and what we implemented there. And this is the ratio and the data source support, the data type support, everything here. And for the Spark version, currently we have a 3.2, 3.3, 3.4, and 3.5. And we will under for Spark 4 support. The Spark 4 will be a big part. So we need there will be lots of work there because the Spark 4 have many new features. And it will be a big upgrade. And when we support the Spark 4, we want to drop the Spark 3.2 because the similar and the UI become too complex. Oh, the CI become too complex.
Do you have thorough testing done already? Like I see Delta Iceberg hoodie on the mix there as well. You see that much in the communities?
Yeah, so currently the Gluten still doesn't cover all the features of Isolate and hoodie. So it's the most used the reader, the write, simple write, it's supported. So there are still many features not supported there.
Like hoodie is, or I guess even Delta Lake has deletion vectors. Do you guys have like merge on read capabilities with these?
No,
No.
the deletion is not supported.
Okay, deletion vectors not, but just copy on write stream.
Yes. Yeah, so here is about the community. Today I checked that we have 161 contributors from more than 25 companies. And currently we have 28 PMC numbers. The PMC numbers are committed before we contributed to Apache. And we have, we are from 8 companies. So we have 6 more committers today, and we are having more and more because many guys are very actively in Gluten, and we have 1.2 star and keep growing today. And we have our ASF Slack channel there. It's called the Incubator Gluten, and we have a Chinese WeChat group with 800 about 400 people there. And most of the Chinese companies, the big companies, already joined and already tried Gluten thing. And there are many questions there, and we have a LinkedIn page. It's called Apache Gluten, and we have a Velox channel and the GitHub issue and the released there. So this is the Gluten, and the chart show how the stars keep growing today. And about the customer adoptions, so the Gluten Velox, initially Velox is used by Metaverse project, so you can see more from Velox. The GitHub issue, the GitHub in PR some issues there, and the Gluten Velox is already adopted by 15 cases, so it's already landed. So what we know from Intel when I worked on Intel and in 11 companies. And there are many companies, they actually don't use the Intel chipset. So they don't use Intel CPU, and they want our support, but they didn't release their names. So we can see many questions. I'd expect that the adoption will be much more than 15 cases, and here it is here. So they didn't notify me actually. And our customer adoption is that they offload the queries with the performance gain and fallback the rest. So it's not the whole bunch of benchmark must offload. So we offload the queries, some queries, and fallback the rest of queries. And currently they use, most of them still use the static measurement. So they have a set of queries. They did a simple test or some test, and then they manually configure that which query will offload, which query will fallback, or just check the query plan. If we have more than two fallback operators, then we fallback the whole query to vanilla Spark. If otherwise we offload to native. Yeah, so it's something like that. So for the big companies, we have currently, initially we have the Ali Cloud, so it's an Intel Alibaba Cloud. So they joined the community very, very early. So when we started the Gluten project about 3 months later, then they joined and they worked with us very closely. And then it's a Microsoft Fabric. We worked for a year. We worked together for 2 years already, and they just released last October. And then it's a Dataproc, Google Dataproc. So we worked with them and for more than 1 year, and they have a J in December, I remember. And then it's currently Watson X data currently I'm working on. And there will be more to come. Here is a bigger company. And the Gluten backend currently is mainly adopted by Citizens and another Bigo. So it's 2 companies use it. So it's a real company. So it's not a toy anymore. So they use the Gluten in their business plan on their business platform.
Progress is awesome. I'm curious if there's a paper published from AWS earlier last year called the Redset dataset, where they took the analysis and usage of the Redshift fleet across the globe. And they published like a lot of these queries. And so I wonder if, have you seen that analysis, and do you have a sense of like how many of the use cases are covered without needing to go back to the fallback or the offload?
Yeah, so some of our customers did the salary number, so about 30%.
30%,
Yeah,
yes.
it's the last, yeah. I'm also currently around already left, yeah. In last October, almost, yeah, 30%. Yeah, so so most of our adoptions currently the customers, they don't want to share more. So they share the number, they share the performance gain with us, but they don't want to do the promotion. And it's one problem when we worked in that actually. And so only one company, they work at Meituan. It's a very large company, the same level as Alibaba. So it's a huge company. And they shared, they did publish some results there. And generally, this is what they have did in last December, last October, I remember. So they adopted about 2,000 ETL jobs, and the average get a resource saving is 40%, and the execution time reduction is 13% there. The 40% of the resource saving is huge. It's a cost reduction actually. And later I will cover why its number means here. And they have an example. It's a job with 30 TB level, 30 TB data. Using the vanilla Spark is 7 hours. Using Gluten is 2 hours. So it's an extreme case. So also you can see that they use this huge data set there, and it does work. And the red chart show how the breakdown, how many queries boosted 1 to 0 to 1 to 1.5 and 1.5 to 2. You can see so the higher than the performance gains, the more performance gains, then the more less queries get. So that is the reason I can show you later. And so this is a real use case. And this is what we tested internally. And we use a single node. And we use lots of SSD, NVMe SSD. It's 7 NVMe or 9 NVMe SSD. And all cores are used. So it's the machine have 128 threads. It's 64 cores, 2 sockets. It's a single node, so there is no cross node shuffling. And so because we use enough disks, so there is no I/O bottleneck. And also we configure it carefully. And then there's no spill. We can configure very large memory. There it's 1.5, I remember 1.5 terabyte memory on this node. So we run SF3P there, and the TPCH is 334, and the TPCS is 302. That's from our side. So when customer ask us, so if they get three times of performance gain, we said, okay, that's our expectation. So for us, it's current number.
Like 30% of the operator uploaded, like roughly, like you said, like 30% of use cases uploaded
Yes.
to like native execution. It's like 3.34.
Oh, no. This is a TPC PS and the TPC is all open rates are offloaded.
All over.
Oh, yeah. 30% is real. Yeah, release open rates.
Oh, okay.
Yeah, so all of the operators offloaded today. But we didn't do much performance improvement here. From an earlier chart, you may see that starting from 2023, the performance doesn't gain anymore. It's about 3 times because then the customer 3 times performance gain is good enough for them. So we needed to create more. And what they need is a real business queries, how the business queries get performance boosted, not the workload. So we didn't spend much time on the workload in Intel. Currently in IBM, it's different story. And this is boost the performance. So without IO, you can see this is expected performance gain. And actually another resource, the cost saving actually is from memory instead of the performance gain. It's because that when we use vanilla Spark, everyone know that the Spark need a very large very large memory for its executor. Otherwise, you will have a spill, you will have ROM. So if we configure the same partition size, if we use vanilla Spark on heap memory, then we need to configure 4 times bigger than the Gluten. If we use off heap memory, we can configure 2 times. We need to configure 2 times more memory than Gluten. So the Gluten the native library actually use much less library, much less memory than the vanilla Spark. Which means that from customer side, given the same memory size, they can start more executors. So in our customer side, what we observed or they told me is that the memory usually is a bottleneck, is a constraint, not the CPU numbers. The some CPUs are even free. So when they use Gluten, they can configure less of heap memory, then they can start more executors at the same time and use more CPUs, then get more performance gain there. Also, on the cloud customers, so they can change from R instance, the AWS ECR instance to the M instance, so they can get the performance cost reduction from that. We have did a test that we change the R from R instance to the M instance. We can get, given the same configurations, we can get better performance than the vanilla Spark on R instance. So if we use M instance, then the vanilla Spark just report OM. Not enough memory. We have to decrease the executors.
So does Gluten has a separate memory pool in addition to the Spark's native memory?
No, it's the same memory pool there. So the memory management is shared.
Like unified and
Unified, yes, unified memory management. But the Gluten use off-heap memory, and the vanilla Spark use some of the off-heap memory, some of the on-heap memory. Then even the vanilla Spark use of heap memory, then they still consume 2 times more memory than Gluten. Yeah, so it's one reason that the vanilla Spark use the internal rule based. So the internal rule based is to cache the same data, to hold the same data size. The Spark need more memory than native library than column based. Also, the Velox also did several technology like the lazy materialization to save the memory. Yeah. So the result is this. Okay, so this is as memory to the customers. Actually, they benefit more from the memory, get more performance cost reduction from the memory, not the performance. So that's why I explained their show me that they get 40% overall cost reduction based on mostly from the memory, not the performance gain. And the performance gain is 13%. And why the performance gain is 13% is because that we know the Spark workload it handles huge data. So you hold the data in S3 or the SSD, you won't have enough SSDs there, so they are usually outbound. And the Gluten definitely it need more L throughput. So then in our test, if we want to get the signal utilization, get the CPU fully used, we need to double or make 3 times more L throughput on the network or local storage or remote storage. So if it's our bottleneck, we still can get to the cloud customers. They still get the benefit because with the same our bottleneck there, then they have a lower CPU, then lower cost from the cloud side. So this is why the cloud providers want to use it. Okay, this is the benefit here. And then the build and the deployment, actually, we spend lots of time. So I have lots of effort to get it done. So currently, we support a static link, which means that we build most of the libraries using this PG, build it under .A, and statically link into libvelox and libgluten to the two SO and compact them into the gluten jar. So it's a single jar. And the class on the worker node, on its worker node, we needn't to install any dependency libraries there, just use the jar and like Spark to distribute the jar to its work. Also, because the different customer have their build environment is totally different. Some of them use CentOS 7, some of them use their private or customized OS. So initially, we want to undersupport the user dynamic link way to undersupport, but we found that it's not possible to cover all the cases. But with the static link, as long as the customer use a Linux-based system, then they can easily build a Gluten using a Docker image here. You can see use the same Docker image, build the Gluten on their system very easily. They needn't to install any other things, just build it. And then just release the jar to the Spark framework and get the Spark framework deploy the jar and get everything done. On the dynamic link, we still support that, and we pack all the dependency libraries in a third-party jar. We have, and the Gluten can load from the jar there, but it works, but because the customer environment is too complex, so this way sometimes doesn't work well. Also, because we need to install some libraries here to pack them. So on different OS, we cannot support all customer need to manually deploy it. So it's very important for the customer to reproduce the performance number. Also, we released the performance reproducer and how we can reproduce the performance and do the analysis and showing this workload there. And there are several PySpark. It's PySpark based. And after the analysis, we can get a breakdown like this. So from this, we can very easily know where the time is spent. So for the TPC-Q1, you can see 44% of the time is on scanned filter, and 60 or 63 is a project like this. And then we can talk about the Gluten next. So in this year, we have a long list. The Gluten, we know the Gluten already adopted by customers, but it's not still mature enough. And we have a long list to level features need to be implemented. And currently we focus on the customer adoptions, and the main issue is listed here. Firstly, the coverage, the bugs, and the result mismatch. Result mismatch is a big issue actually. When you implement it in Velox and compared to vanilla Spark, then the performance, the result doesn't match. Usually it's caused by the function implementation, or sometimes it's caused by exception handling. And the UDF support customer, they have their private UDF. We do have a UDF workload, the framework, so the customer can implement their UDF in native and build the UDF as a third-party SO file and distributed by Spark and then configure it in Gluten. So they needn't to release their UDF to source code to Gluten, so they can build their private UDF libraries and thanks to Gluten. But the problem is that the customer UDF is also very complex. For a simple UDF, they can easily port to Velox. But for a complex UDF, especially when they use some Google JARs, third-party JARs, many JARs, so which means they need to implement those third-party libraries in native and well, eventually it's not possible. So it's actually one big issue for the customer adoption there. And the memory management, we implemented it, but we still have many issues. It is still there, and the configurable fallback policy. So and the how we fallback queries. So that's what I mentioned. The Google guys just implemented this feature and contribute to Spark, contribute to the Gluten. And we can easily decide which query should fall back, which states should fall back, and the performance issues. We still have the spill and short. So we noted that if your workload have a spill, large spill size and a large short size, the performance may be the same as vanilla Spark. And the full data lake support, we did the basic support, but it's not fully supported yet. And the dictionary support in Shuffle, it's another big part. The dictionary is a unique feature for the columnar shuffle, so you can implement a dictionary and before you shuffle the data and after you shuffle the data, then you can decrease the shuffle data size very largely. Once the Spark gets a less shuffle data size, then the Spark performance will improve. And then it's Spark 4 support, PySpark support.
The iceberg and the support that you mentioned there, is it mostly what we mentioned before, positional deletes, deletion vectors, and MOR support, or the other components that you guys are looking to solve?
I think the MOR support is one.
Primary,
Yeah, it's a major part, and also there are many others. So I don't know the details. Yeah.
Are you finding good traction engagement with the communities?
Yeah. So the dictionary, the iceberg support is mainly developed by the Alibaba guys. Yeah. And the community in GitHub issue list, they have an issue to cover all the missing features there. And then it's the Gluten design principle that we want to use a standard query plan representation. It's a substrate, and we want to use standard data format Apache Enroll, and we want to plug in many different libraries and accelerators. So here is an example how Apache Enroll and the Velox can work together. We send the substrate plan to Apache Enroll, gather its many today, it's only a CSV scan because Velox doesn't support the CSV scan. We get the Apache Enroll data and then send the Apache Enroll data to the Velox, and the Velox convert it to Velox native format, internal format, and then start the Velox pipeline and then get back to Spark. So we can, in the same stage, we can do the, but currently we don't support the CleanHouse and the Velox work together. So you either select the CleanHouse or Velox because no customer asked for this feature. So we need to implement that.
Yeah, on substrate, you said 30% of operators are covered, right? Now, are the operators in substrate sufficient, or maybe
No.
you see that there are gaps in substrate?
Yeah, so it's a good question. So currently we use our internal substrate. So we forked one version of our substrate in early time and developed the other one. So it's instead of the Gluten today, it's not the upstream substrate anymore.
I see, okay.
Yeah.
But is the plan to send it upstream?
Yes. So we want to, but in Intel, it's not a high priority for us, so we didn't do it. And the Apache Arrow guys, the virtual data, one guy from virtual data, he used to work on this. He wanted to contribute the features to the upstream substrate and then get the Gluten use upstream substrate. And yeah, I said that it's a good work, so definitely we need that, but currently it looks like it's out in our effort.
I see. And so of the 30% of operators, right, how does that compare when you use Spark streaming, for example? Is it less covered or is it about the same?
No, the Spark streaming is not supported.
Okay, not
Yeah,
supported.
only the SparkSQL supported.
Like the structure streaming.
Yes, Spark, yeah,
It's not, okay, Gluten only will.
for the SparkSQL. Yeah, so what happened is it's because that we want to add the accelerator support. So in Intel, we want to add, even previously, we want to add our GPU today. And currently in IBM, we want to add the support from NVIDIA and the GPU support from NVIDIA. And we entered definitely, we did many tests on Rapids. So we did compare Rapids performance and the Gluten performance. Also, we heard from our customers on stories. And what we want, or what my opinion is that so you cannot offload everything to GPU. Some operators it's I will put like the I will bond it, you can still use the Velox is enough and offload some other operators to substitute to the GPU. It will be faster. And we want to under support under support of the other libraries, GPU libraries. It will be one main work in IBM now. And also I worked today, I can work with the NVIDIA guys. So I did work with Pedro and the NVIDIA guys on this under the substrates or under the GPU support. Also, there are some other companies like the Velox, they want to use their GPU libraries. And also one company, it's called Neuroblade. So they just released their gluten, not gluten based. They worked with us also to offload the gluten, the Pakistan and many other operators has aggregated to the FPGA. They wanted to redo some of our FPGA work. So we hopefully by end of this year we have more accelerator support there. And also,
Sorry.
yeah.
Really quick.
Yeah.
Velox seems also provides the functionality very just.
Wait.
Yeah, it's two way. Like, what's the difference between you offload on Gluten side or you offload on Velox side?
Yeah, it's a good question. So the wave support is inside of the Velox. It will be transparent to Gluten. And we send the substitute plan start a Velox pipeline. The Velox pipeline can offload some part of the operator to wave operators and others off back to the wave. And what we did here is that we want to get the library, for example, the NVIDIA libqdf, we want to get that to support the substrate plan and get the Velox data command. In that way, the libqdf needed to send the data to direct or needed to integrate into the Velox. So it can be a third-party library, just support the substrate input and get the other data. Then we can plug in into the Gluten. That's the difference. Yeah, so the wave will be part of the Velox inside. It's not it needed to support the substrate. Yeah, so it's another thing I worked with Pedro to upload to test the wave performance as well, and I wanted to get the most efficient or most maximize the cost reductions. Yeah. Yeah, so actually, when we started the Gluten project, we not only wanted to upload to the SparkSQL, we also wanted to offload the Flink. I know that there are many guys, or many customers, they are very interested to offload the Flink operators to the native also. So currently, the Alibaba, they already have implemented this part to offload to the Velox, but it's not open source. So we initially worked with them and wanted to get the Flink support in Gluten, but currently Intel, we don't have enough resource. We don't have enough hackers on this project. And in IBM, I'm not sure. So hopefully we can get some more work. So the community, the Spark community said, or the Gluten community said that if the Gluten team so start a Flink, then they can definitely follow. So they need some guys or need some expert to start it or to lead them. The Flink effort will be more bigger than Spark actually. It's because the Spark, because we have a Fulton, the Databricks already have a Fulton, they already implemented this plugin. Also the Databricks, the NVIDIA guys, they already added some features there. Also we added, so we can easily offload to the native. But on Flink side, everything is important. We have to implement the plugin, implement the plan, version, everything.
Does that look like contribution to Flink, or does that look like contribution inside Gluten?
Inside the Gluten, just like the do today, so it's a plugin. We want to do that.
But does
plugin to Flink.
I see. So Flink already provides the interfaces that will let you plug in.
I don't think so. So it's that's what I mean. That they don't have this spot and how we need to implement.
Okay.
So are you mentioning you're gonna get performance benefit from like doing that for Flink? Since Flink is mostly focused on streaming and this is more like Velox is more focusing on like vectorized columnar kind of format.
And I think that the Velox it's a native library, so it's offloaded the Spark operator, the SQL operators. So for the Flink, they use the SQL and the SQL operators, then they can offload it to the Velox. And the Alibaba guys, they did already publish some result and using it's still in a POC, it's not mature enough yet, but they already published some.
And they already see performance gain.
Yes, yes.
Are they in Gluten or they're using their own like native?
Their own. No, they use Velox, but they didn't contribute back to Gluten. Yeah, so initially we talked with them and we worked with them, we helped them to start the project internally. But the band is that in Intel, we don't have a hacker, and that time they even want us to work with them together on the Flink, and then they can build band. But the result is that we helped them to start the project, and then they do their own.
So they
Yeah,
don't
we-
use it like Gluten at all, they just use straightforward Velox.
Yeah, they use the substrate, the same idea of the glutens.
In terms of, you covered deployment earlier,
Mhm.
right? What does the deployment story look like in something like EMR? Is it just about getting the jar there, or is that,
Only a jar or plugin jar.
I see.
Yeah, if you use a standard build, then it's only a plugin jar, yeah, or a gluten jar, and configure it into the Spark plugin.
I see.
That's all.
Okay, and of the 30% of the operators, is it possible to do some compile time checks in terms of how much of this query will?
Yeah, it's a good question. So that's what the Google data block team or the member in the data block team, they contributed back to gluten recently.
They contributed it, sorry.
Data block.
Data
Data block, yeah. So they implemented a framework, analyzed the event log, the Spark event log, and the gluten event log, and then they check out if this query can be offloaded or can get benefit from gluten or not, from Velox or not. If it can, then fallback, or then offload, otherwise fallback. Yeah, the framework is very complex, but it's very useful.
I see. So there is contribution from AWS quite a bit, is it?
I did talk with the AWS, but I can't say more.
Okay.
Yeah.
Oh, sorry. Okay.
Yamar, AWS Yamar.
With Link in the picture here, is Pymon also a consideration, as we talked about?
No,
Yeah, probably also since they haven't contributed back in grace.
Okay, so that's our slides. So let me see. Wow. Oh, sorry, the performance, the pen. Okay, so this is the last slide. So here we have was again, it's a self-Slack. You can join and you can find me there. And then we have a chat, we chat group there. So for any questions, you can post it there, or you can submit the PR issues in GitHub. So we can work together to make it more mature. Okay, that's all over the slide today, and hopefully I have introduced the most part of the gluten, the simple, and yeah, hopefully it's useful to you guys. Thank you. So if you any questions, so
So not sure if you mentioned it before, I was late to the party, so. In addition to the Velox backend and the ClickHouse backend, or is the community considering other backend like Data Fusion?
yes, so there are some companies that mentioned that they want to add the data fusion backend, and my answer is that yeah, we can definitely support that. It's very easy. You can add that. We can help them. But I asked them how many of you, they asked me how much effort. I said that it's the effort is not for a single person. It's not possible. So it's a bit complex, especially you need to make clear all the GNI cost, everything, and under the data fusion support. So if you are a team in some companies, definitely we can help to do that. And yeah, so another issue is that we in previously Intel, no customer asked for it, just interest from one company. Yeah, and also actually I talked with the actual guys, what's the name? Yeah, I talked with them, and when they started, before they started the community project, I talked with them, I shared some shuffle things with him. And at that time, I wanted them to work with me together on the Gluten project, contributed under diffusion, tapping directly to Gluten, but unfortunately I didn't. So they started their commit. Yeah, that's it.
Question. Normally Harold has a lot of questions. I don't know what happened to Harold.
Not today.
Not, okay.
Well, I'm wondering what that last symbol is in written Chinese.
It's a it's a WeChat group. WeChat group. The name is Gluten.
Last symbol.
The
What's the X in the box?
action box.
No,
No, the last.
your last one, other direction.
WeChat
Keep going, keep
the
going,
Gluten
keep going.
使用者社区
The last one.
That's X.
区。Oh, you mean the last action? Oh. It's the community here. Community. X. X in your box.
Sorry.
Good question.
Yeah.
That's my question.
Really, you have my question.
Okay, thank you, Bellevue. Thank you very much.
Thank you.
And thank you, everybody, for coming on Thursday here. So thank you again. Thank you. Okay, Askia, you can stop recording.